Hello everyone. In this video we're going to be solving a non-standard equation. Wow, this is so non-standard. We have trigonometric equation on the left hand side and a polynomial on the right hand side. So you can't just solve it by general standard means, such as, you know how we have for quadratic equations we have the quadratic formula, for cubics we have a different formula, or if you have a rational equation you can factor it, so on and so forth. We have to think differently. Here's the first thing we can do. I hope you noticed that on the left hand side we have a difference of two squares. What is that? Let's talk about difference of two squares, which is super duper important. If you have an expression in algebra such as a squared minus b squared, that can be written as a plus b times a minus b. The expression on the left hand side is called difference of two squares, or you can call it dots, and it's factored as follows. So we can go ahead and factor this cosine to the fourth minus sine to the fourth as difference of two squares. How? We can think of this as cosine squared squared, and the second one as sine squared squared. Therefore, it becomes a difference of two squares. If you factor it accordingly, cosine squared plus sine squared, and then you'll get cosine squared minus sine squared by this formula, right? Okay. Now, what is so special about this? I'm hoping that you did a little bit of trigonometry and you recognize this identity. And if you said 1, you're right. Cosine squared plus sine squared is always 1. So this expression turns into cosine squared minus sine squared. In other words, the difference of fourth powers for cosine and sine is the same as difference of squares. Awesome. Now, I got a simpler equation on the left-hand side, which is right now on the right-hand side, and then that's equal to x to the fourth plus 1. Let's go ahead and rewrite our equation. Cosine squared x minus sine squared x equals x to the fourth plus 1. It's still a little bit of problematic because what can I do with this, right? I mean, I'm thinking about it like, can I square root both sides, square both sides? Well, one of the things you can do is you can replace sine squared with 1 minus cosine squared, or do something like that. But that's still not going to help. So we kind of have to turn this, first of all, let's turn this into a single trigonometric function. And that's possible. And again, if you know your identities, if you know your formulas, definitely you should memorize them. Sorry, there's no other way. This, you'll recognize this is double angle for cosine. Cosine of 2x. Okay? And then we get x to the fourth power plus 1 on the right hand side. Now, did I tell you I'm going to show you a graph at the end, which is actually pretty cool, and graphically it'll give you a better idea. Okay? So this problem is still non-standard, but here's the thing. I can kind of look at the extreme values. First of all, note that cosine is bounded. So we can safely say that, hey, cosine of anything, cosine of alpha, is always between -1 and 1, inclusive. Since cosine of 2x is cosine of something, and some people are going to write it in parentheses if you want, that's totally fine. You can do that. Cosine of 2x also needs to follow this rule. Great. What about the other part? Okay, you got a boundary for those. But this one here is x to the fourth is actually always greater than or equal to 0. Why? Because it's an even power. Great. So when I add 1 to both sides, this is going to be greater or equal to 1, which is greater than 0. So indirectly, this means, or using the transitive property, x to the fourth plus 1 is always greater than 0. Right? Okay. How is this going to help? Actually, I don't think I do need this to be greater than 0, so I could probably leave it at that. Yes. Now we got these two things. Let's take a look. This expression is between -1 and 1, and this expression is greater or equal to 1. I don't really care about the -1. I'm going to focus on here. So I'm basically saying that cosine of 2x is equal to x to the fourth plus 1, but this expression is less than or equal to 1, and this expression is greater or equal to 1. How is that possible? It is only possible if they are both equal to 1 at the same time. Make sense? Awesome. Let's go ahead and solve it. So this implies that cosine of 2x equals 1. And this is a very strong conjunction. Is that how you say it? Okay, anyways. This is very strong. It means both of these equations are equal to 1. So, in other words, from inequalities, using inequalities, we can solve some equations. And this is one of them. Great. So this is a system, so both equations must be satisfied. And let's see how we can satisfy them. Cosine of 2x equals 1 is a little bit more complicated. So let's go ahead and solve this one first. I'm lazy. What can I do, right? So x to the 4th equals 0, and x is equal to 0 from here. Now we're going to check. We don't have to solve because this equation has quite a few solutions, and actually infinitely many, to be honest with you, or to be accurate. But x equals 0 is the only one that comes. And does it satisfy the first equation? It does. Therefore, it's a common solution. And guess what? X equals 0 is the only solution to this system or equation. It's an equation originally, right? Okay, great, good. Let's go ahead and take a look at the graph and we'll finish up. So I graphed both of these functions for you, cosine x to the 4th and sine x to the 4th, their difference. Obviously, it's the same thing as difference of two squares, which is the same thing as cosine of 2x. So this is basically just cosine of 2x. In other words, it's just in disguise. And that's why it looks like a cosine function. Look at that. It has a max at 0 and a 0 afterwards, another 0, ups and downs, ups and downs. Kind of like a sine curve, but it's shifted, of course. And guess what? X to the 4th plus 1 is a curve that has a minimum at 0, 1, and they intersect or touch or are tangent to each other at 0, 1, whatever that means. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.